Hi, and welcome to today's Foojay Podcast. Today, we're going to be talking about the number of different Java distributions in the ecosystem.
Welcome to the Foojay Podcast, all your news about OpenJDK.
So with the release of Java 17, this is a really cool new release with a lot of features. Now, my personal favorite is JDK Flight Recorder, but it also has records and just generally a lot of really good stuff. And most importantly, this is a long-term support release, which means many people will go from Java 11 or Java 8 to 17, giving you everything that happened in between. But there are a couple ways to get this distribution. Oracle offers a JDK under the new free license as well as the GPL distribution. Microsoft offers their own JDK distribution based on OpenJDK. Azul offers Zulu as a free OpenJDK and Zing as a commercial distribution. Bellsoft offers Liberica, a free OpenJDK distribution. Amazon offers Corretto, their free OpenJDK. Eclipse offers Adoptium and Temurin, formerly adopted OpenJDK. Adoptium also offers J9 as a different JDK. Red Hat offers their JDK distribution, which they just call OpenJDK. SAP offers SAP Machine as a free OpenJDK distribution. And separately, there are other tailored JDKs for certain purposes. GraalVM is a JDK that operates as a hotspot OpenJDK, but also steers toward native machine compilation. And Tornado VM is a VM that intends to run Java on GPUs. And we're leaving out Alibaba Dragonwell, whose JDK, I think, merged into Adopt. Now, the topic for today is why there are so many JDKs, how they're the same and how they're different, as well as how they collaborate and how they compete. And I'm really excited today to have a number of guests from different parts of the software ecosystem, both Java and a peer software language community, to help get a perspective on this ecosystem.
So my name is Ashley Williams. I do not come from the Java community. I'm the peer perspective. I am a member of the Rust programming languages core team, and I was additionally the founder and original executive director of the new Rust Foundation.
And I'm Simon Ritter. I'm the deputy CTO at Azul, and I am from the Java community and the Java world, having joined Sun way back in 1996 at the same time that JDK 1.0 came out. So I've followed Java all the way through its history, working at Sun, then at Oracle, and now at Azul.
I'm Dmitry Chuyko, also from Java world. I work as engineer in Bellsoft, and previously in Oracle. And before that, I participated in many Java applications development.
And I'm Erik Costlow. I handle developer relations for Contrast Security, focusing on securing applications from the inside to detect their various security vulnerabilities.
Hi, everyone. I'm Bruno Borges. I'm on the PM team here at Microsoft, and I work with Microsoft Beautiful OpenJDK with Martin Verberg and other folks, and I'm happy to be here.
All right. We generally start the podcast by finding certain articles that have appeared on Foojay. And I think last year there was an article written by Marcus Hurt that was called Fantastic JVMs and Where to Find Them. And what Marcus did was to just summarize a couple of the different JDK distributions that made JDK Flight Recorder available and had backported it into JDK 8, as well as discussing the organization that provided that JDK and where to get it. So Simon, can you just give us a recap of that article and certain things in the ecosystem about it?
Yes. So what we saw was a few years ago, because it's actually now a few years ago, Java SE9 came out, and that was what Oracle will tell you was the last major release of Java, meaning that it had several years of development effort behind it. What we've seen since then is the switch to a much faster release cadence and a predictable release, where we have 2 releases every year, one in March, one in September. So as you quite rightly pointed out, last month we got JDK 17. Now, as a result of that much faster release cadence, Oracle also made the decision to change from providing updates and providing support for every release to using a long-term support strategy. And what that meant was that there were going to be 3 years between long-term support releases, so every 6th release, and they would start with JDK 8, having extended support, then JDK 11, and now we have JDK 17. And the significance of that was obviously that we had updates provided for only certain releases. The other thing that changed was with the release of JDK 11, Oracle then decided to change the license for their JDK, the Oracle JDK. In the past, what users have been used to is this idea that Java is free, meaning that you could go to java.sun.com or java.oracle.com as it then became, and you could download the JDK from there and you could use it for free. You could put it on your desktop, you could put it on your laptop, you could put it in your servers, in the cloud. The only limitations from a licensing point of view at that time were on mobile devices or embedded systems. Now, with the change from what was called the Oracle Binary Code License to the Oracle Technology Network License Agreement, with JDK 11 was that there were much more restrictions on where you could use the Oracle JDK for free. Essentially, there are only 4 places. One is personal use, if you're at home playing Minecraft. Secondly, if you want to use it for development or testing, then you can do that. But for more commercial type of deployments, the only places you can use it for free are either with Oracle approved applications, meaning their middleware and their end user applications, or in the Oracle Cloud. Anything else would require the purchase of a Java SE subscription from Oracle. Now, that has led to, as you quite rightly point out, a proliferation of distributions of OpenJDK. OpenJDK is the open source project that was created by Sun back in 2006, 2007, that allowed people to download the source and then build it and make their own distribution. It's covered by the GPL v2 license with class path exception. And so you can just download the code and you can run the build scripts and make it available to people under that license. And so we've seen a lot of companies do that. You can go to Bellsoft, you can download Liberica, you can go to Azul, you can download Zulu, and so on. And what that's meant is that now people are looking at, okay, so all these different distributions, what choices have I got? Which one would I choose? And that's where it leads into kind of making distinctions between these builds in terms of what are the differences, but what are the commonalities between them. I think the one big thing to get across from this is the importance of what's called the TCK. The TCK is part of the Java SE specification. That's developed through the Java community process. Each version of Java has a JSR, a Java specification request. And part of that is this technology compatibility kit. Somewhere between 100, 150,000 tests, depending on which version of Java you have. And in order to say that this is Java, you need to run all of those tests and then verify that you have a compliant version of Java.
All right. So it sounds like what you're saying is that each of these distributions maintains a baseline of compatibility so people can just choose and have their application run generally the same, whether they choose Azul Zulu or Dmitry Bellsoft Liberica. So how do you two coordinate between different companies, not necessarily by talking, but what exactly does the TCK do to enable that?
Right. So the TCK is this very large number of tests, which it's not exhaustive because you're never going to have a truly exhaustive set of tests, but it's very comprehensive. What it gives you is a very high level of confidence that if you take one TCK tested JDK and you move your application to another TCK tested JDK, then the application will run in the same way from a functional point of view. It doesn't mean it will run the same point of view from performance and so on, because you can have different implementations. You mentioned J9, Azul will have a different one called Prime, used to be called Zing. They still pass the TCK, but they don't do the same things internally. So you'll get different performance characteristics, but they will have the same functionality, meaning that you can run the application without having to change any code, without having to recompile. So that's the sort of level of commonality, is by using that testing to give you functional equivalence.
So Ashley, how does the Rust community deal with different distributions? Is it generally speaking that there's one Rust distribution that's provided by the Open Source Foundation, or are there a couple different Rust distributions that are provided by different actors in the Rust community?
Yeah, so at the moment we have a single release. And that release is managed by the teams. We now have a foundation, and so the foundation is able to kind of be the holder of that. The Rust trademark policy does not currently allow folks to distribute a Rust called Rust beyond just the foundation. But I think there's been a couple of interesting questions about whether or not we would like that to see that change. But yeah, for the moment, there is the single one that's run by the Rust release team.
All right. So, Dmitry, as Bellsoft has Liberica, that's an OpenJDK distribution and relatively similar to the free Azul Zulu, based on what we talked about with the TCK. What are the key differences between these two distributions?
That's a good question. First, really, OpenJDK proliferates, but I would say it started even maybe much earlier than Oracle changed the licensing policy, because there are so many different users and so many customers with different needs. So some JDKs aim at specific needs, and teams also work slightly differently. For example, you may face what we do if you use JetBrains products, because we also support JetBrains runtime, which is one more OpenJDK distribution. And if you use, for example, Spring and build your containers, you will get Liberica there. You will get it supported in VMware Tanzu Cloud. And if you even build Spring containers, Spring Boot containers as native images, they will be built by Liberica Native Image Kit core, which also contains Liberica as its foundation.
All right. So, Bruno, there was a survey recently that talked about the different JDK distribution that a number of developers were choosing. And I know Adoptium or Adopt OpenJDK was pretty high up in that percentage, with a large number of people choosing that as their distribution. What should people know about that? Why was Adoptium so popular on these charts? And what's the state of that ecosystem?
Well, I believe the reason that drives Adoptium or Adopt OpenJDK, previously known as, is the idea that it's a vendor-neutral JDK distribution that builds on top of the work of contributors, of vendors that help maintain OpenJDK versions, open source versions. So we see Red Hat contributing a lot, and Azul Systems and Bellsoft contributing a lot to different OpenJDK JDK update projects. So older versions of Java that are kept and maintained up to date as an open source project. And then Eclipse Foundation, and now Eclipse Adoptium project, gets those source code and builds binaries that are considered like vendor neutral. So I think that's one of the reasons that drives a lot of its adoption and usage in the market. But of course, Eclipse Adoption does not necessarily provide any commercial guarantees or commercial support contracts for customers that may require some more like commercial agreements and needs. So for the average developer, it's something that is interesting, but for large corporations, because if a company that has some needs like SLA or compliance or something like that, they may actually have reasons to go with a commercial agreement. So Adoptium drives a lot of that usage, but does not cover all of the use cases. So that's why I find it important to have this marketplace of OpenJDK distributions with different companies. And that's perhaps the strongest, the biggest strength of OpenJDK project in the Java ecosystem in general.
So I was talking a little bit about this with Erik ahead of the show, but as somebody who comes from an ecosystem that, at least at the moment, currently has a single distribution, it's always been curious to me how, when folks are choosing a JDK, do you find that they are choosing those JDKs based on features, which could be like performance or some type of support, or do you find that the vast majority of people pick based on like price?
Well, I'll add a comment here that price it's one of the last criterias for picking a product in general, not just OpenJDK here, but a product in general. sure, it drives decision a lot, but it's not the biggest concern. The biggest concern are other things. Price is like the last thing. It's like when you go buy a car. Yeah, we'll talk about the price later, because it is the last thing that companies look into. They will look into price, of course, but it's one of the last things that they will look into. First, they will make sure that the checklist is met, and whatever commercial distribution they have to pick covers this, and that, and then they will go with price. So there's a lot of competition in that, and I respect Azul Systems and Bellsoft for competing very strongly with Oracle in this space, and having a very solid price competition there. But because, at least on behalf of Microsoft, we don't charge for the Microsoft Beautiful JDK, it's hard for us to say anything further. But as a Java developer, I would say, again, it's good to have the that many options, so we can choose which one.
Okay, so we have the free JDK distributions like Adopt that people can just download, but for an organization that needs the full support, there's typically the paid commercial where you get support and some other features. So Simon and Dmitry, what are some of those differentiators in Azul Prime and Bellsoft Liberica that are the difference between the free version, which you can get gratis without paying, and the commercial version where you get support plus something else?
Yeah, I mean, so first thing I need to just to clarify there, Azul Prime is a different product. So it's not the OpenJDK one, or it is based on OpenJDK, but it's not free. Zulu is our free distribution, and then we have Azul Core, which is the supported version of that. When we look at the differences, it really comes down to a number of key factors. And obviously price is going to be one of those, which people do. I'm going to disagree a little with Bruno here. People do look at that fairly early on. It isn't just straight looking at the features. They do think about the price as well quite early. But certainly if you're in an environment where compliance is an issue and you need particular support for your software, then that's a key thing. But obviously SLAs are important as well. And what I mean by that is that if you're maintaining software, and we need to make a distinction between maintenance and support here. If you're maintaining your software and you need to keep those updates coming through, then there's a real critical thing as to how quickly you get those updates made available. And there's a timing for when updates can be released. There's an embargo on updates up until a certain point. And 4 times a year, we get an update to Java, which happens in January, April, July, and October. So we'll have an update, I think it's actually next week, I think. But anyway, so we get an update, and when the embargo ends, Oracle will release their update. They're always kind of the first to do that. And then other people will follow after that. So how quickly you get your updates after that is critical, because if you have to wait days or even weeks until an update is made available, then because security patches are delivered in the update and the security vulnerabilities, the CVEs that are addressed, are included in the release notes, that means that the moment that update comes out, all of the security patches, the vulnerabilities that have been in previous versions, are exposed and made public. So if there's a critical vulnerability with a CVSS of 9.0 or 10, then you may want to get that update installed on your systems very quickly so that you're not exposed to those vulnerabilities and people can potentially break into your system. So that timing of how quickly you can get your updates after the embargo is ended, then that's a real critical factor of that. There's other things as well in terms of like support, in terms of how wide the platform support is, whether you've got 32-bit versions, example, if you're still running Windows XP, do you get a version for that will run on there? Various other things like that are kind of what people will evaluate.
And I totally agree with Simon. The support is very important story, and people do look at support price and support SLAs, how responsible support is. Do get quick answers, do get updates, and free updates and updates for commercial customers. They go approximately at the same time, not exactly, but approximately at the same time. Again, this race is an important quarterly exercise. Like last release, for example, Liberica was released right after TCK was made generally available, which is, it's a challenge. And there are many factors, really. Performance may make you thinking of different virtual machine. Like there is hotspot virtual machine, there is Zing, there is J9, there is Substrate. In our space, you may decide to use native image, right? So it may give you some restrictions then you choose. So the implementation is not a single one. In Java world, we have specifications, we have testing kits, but we are not limited to a single implementation. Maybe that's the difference.
Got it. So stepping out of the single implementation, there's notions of when things become available, when they become supported, or when they become unsupported. So Ashley, what are some of your thoughts on the concept of long-term support versus short-term support and the overall release cadence?
Yeah, absolutely. So Rust is a programming language that has the benefit of coming kind of more recently. And so we were able to take a look at how a lot of other languages did their release process and then kind of learn from those experiences. And so I think one of the experiences that really drove the Rust release process, which I'll explain in a second, was the fact that we actually had a fair number of folks from the Ruby world who were participating originally in Rust, which I think surprises some people because the languages are quite different in certain ways and very similar in others. But Ruby releases on Christmas yearly, and that is quite a long release cadence. And it often leads to this kind of like rush up of like, oh, we got to get everything in. And honestly, I thought about this when I was listening to you all talk about kind of Oracle releasing things. And it's like this big, everything rolls up into this one thing. And then everyone's got to kind of like shift over to this new version. And this was something that I also experienced. I was originally in the Node.js world. And for a while, that's kind of how changes happened. And so in Rust, one of the things, we love our little slogans. We're all extremely online, but we have this idea of stability without stagnation. And so what was important for Rust was we need to be able to change the language, but we need to be able to change the language in a way that isn't going to constantly break people. And so we run a 6-week release cadence, and we have 3 release trains. One is nightly, which is released nightly, and then beta, and then stable. And there's many little factors within that, but they kind of cascade through each other on this cadence. And then additionally, we have something called additions, which is where if we need to make breaking changes, we're able to do work within our compiler using an additions flag in the configuration that allows you to use one addition of Rust, say with a new keyword, and a new keyword would be a breaking change, with an old edition of Rust that doesn't have it, and the compiler is able to make those compile together. So this is all to say, there's been tons of conversations about what an LTS like program would look like in Rust, but we've done a lot of work to try and make the need for an LTS significantly less by making it a lot easier for the language to change and for folks to basically be pointing at head without that being like a constant struggle and feeling like their code is consistently breaking. So you can, in general, kind of like update your Rust very, very frequently, and it is not as tumultuous an update process as you may have in other community ecosystems. So I definitely think that's interesting, and I'm kind of curious to hear like if there was like a more frequent like release cadence for Java, and if there were potentially like less. The word breakage in technical communities is a little too negative, and I don't mean it that way. But if that was reduced, do you think you would see as many of these JDKs, or is this proliferation of JDKs kind of a response to the fact that like transitioning between versions of Java is complicated?
Yeah, it's interesting to hear that because obviously there's a very different model being used here, and that may be partly to do with Rust being a newer language than Java. And what we find is that Java being 26 years old now, there's a lot of kind of, and I'm going to use the word embedded, but not in the sense of embedded systems, embedded Java usage in particular enterprises. And that's one of the things that is a resistance to change. There's a lot of people out there who are still using, I mean, we have customers who are using JDK 6, we have customers using JDK 7, we still support them, and they just don't want to move off there because the work involved in taking an application, having to recertify it on a newer version of Java, it's like, it works. So why do I want to move it to a newer version of Java if it's just going to work again and go through all that testing? So that's one of the kind of reasons, is because we have so many people using applications over the last 20 years, then there is this reluctance to sort of move as quickly. And certainly the kind of customers that I know I talk to, when you're talking to banks, when you're talking to some of these more conservative with little c customers, they don't want to move very frequently. I know there's, a drive towards CI/CD, but there's still a lot of customers who want this, long time between releases, and they can make that move. I mean, it's one thing we haven't actually mentioned here is that with the release of JDK 17 last week, Oracle also announced that they're going to change the cadence of long-term support releases. So we've had 3 years between JDK 11 and JDK 17, and now they want to only have 2 years between long-term support releases, meaning the next one will be JDK 21 rather than JDK 23. So the idea is that you test frequently, so you can try out these new versions as they come out every 6 months. And then when you need to make that switch from 11 to 17 or 17 to 21, you've already done a lot of the testing, so it's easier to make that switch. So it is a bit of a different model.
Simon, I actually want to jump in here and just add some dated context to this. As you cited the organizations that are still on Java 6, I just want to emphasize that was released in about 2006. So things have significantly changed and sped up since then. And I think what we're seeing is people who are on the latest and greatest versions, like those who go between, Java 14, 15, 16, they tend to be more rapid in their adoption of the newer JDK distributions, whereas the organizations that are on kind of their legacy software from the early 2000s, or indeed even the late 90s, that was a time when you changed significantly less frequently, because a lot of people, there was not much broadband. They would connect through like America Online with their 56 kilobit modems.
Just one thing to add to that, it's interesting to look at the SNCC JVM survey that they did a few months ago. And if you look at the usage breakdown that they had in that, okay, it's a survey, so take it as you will, but it was very interesting. They allowed you to include multiple answers to the questions, whereas previously it had been one answer for one question. And what we found was that JDK 8, JDK 11 had sort of similar levels of deployment. So there's still a lot of people using 8, there's still a lot of people using 11, obviously, and it'll be interesting to see how many people move to 17, or how quickly they move to 17.
Yeah, I noticed the big spikes on the long-term support releases.
It's interesting to compare speed releasing, for example, Rust and Java. So at the same time, one is faster and slower than another, because if you think of speed of getting next big version, it's probably slower, right, with Java. As Simon explained, people move slowly, and versions come out not so often, but we don't have kind of nightlies, right? So again, it's slower. But at the same time, if someone has, for example, a support contract and needs a fix from some vendor, or a vendor decides to make a fix, then we can release fully tested JDK version with that fix. But that would be a custom version of kind of official. And that fix goes to OpenJDK and becomes some public change that goes into some update release. And update releases are also different. Probably we'll talk about that. Again, it may be slower or it may be very fast if you look at the perspective of your risks.
I think there's a fundamental difference between OpenJDK/Java versus other languages like Rust and Go, which is those languages are languages and compilers. They don't have a runtime per se, like OpenJDK has. So that fundamental difference has a significant impact in how enterprises adopt the language. One of the reasons Java got to be updated very slowly in the past was because customers and developers were deploying the Java runtime on desktops and servers, and then applications would be deployed on top of that runtime. So customers were always like concerned, oh, I cannot just update my runtime because I have several applications and I don't know all of the applications that are running on top of that runtime. So I cannot just go and replace that runtime with the latest and greatest because I don't know if my applications will break. I cannot test all of them either. The applications were already compiled and the bytecode will run on top of that runtime. But when it comes to other languages, there's no such thing as runtime. You just compile the application and run the application, the binary. Right. So that's also an important difference. And when we talk about OpenJDK from different vendors, we're not talking about different Java languages or different versions of Java languages. We are only talking about different runtimes and patches and enhancements. So Azul Systems, Bellsoft, Amazon Corretto, Alibaba, SAP Machine, Red Hat, OpenJDK, and so on. All of these are just the runtimes to run the bytecode that got compiled for a particular version of the Java language. So the runtimes of these different vendors do get different patches and enhancements that get backported from the tip of the latest version of Java to these older long-term supported versions of the runtime. And that's a significant difference in why customers don't necessarily move forward that fast. But honestly, in recent years, I think we've seen that customers are more courageous now, and they have been updating their runtimes much faster than in the past.
Okay, so the way that the Java handles this structure is a developer compiles their code to bytecode. That bytecode is now designed to run this exact same across each different JDK distribution per the TCK, which we talked about earlier. And frequently there would be a runtime environment. And it sounds like one of the differences or the reasons that we have multiple JDKs is due to the focus on JIT or just-in-time compilation versus ahead-of-time compilation. And actually, with some of the recent changes that have gone on in Java recently, with like the creation of custom runtimes through JLink, where the JRE is now embedded with the application, or GraalVM native compiles something, it seems like it's going to be easier to distribute individual standalone binaries.
Yes. I see a lot of hands raised, but yeah. I mean, that's always been one of the advantages of Java, having the runtime. And I think Bruno made an excellent point there in terms of the fact that is a difference between Rust, a fundamental difference between Rust and Java is the runtime. And that's the thing that people actually want to update. It's not about updating the language quite so much. Obviously, with a compile time thing, you can move to a newer version much more easily than you can on the runtime. But one of the big advantages, and I was having this conversation with somebody just yesterday, of Java is bytecodes. Not because of the portability that it gives you, but the ability to then do just-in-time compilation. And just-in-time compilation has more opportunities for optimization than you do with ahead-of-time static compilation. There's things like speculative optimizations that you can take advantage of in Java that you can't take advantage of in statically compiled code. Yes, you can use profile guided optimizations, but it's still not going to give you that level of ability to optimize on the fly that you get with JIT compilation. So there's things like that. And I'm sure Ashley's going to say something about that.
I mean, I think it is potentially a bold thing to say that it is quote unquote easier to optimize something that's JITted than not.
I didn't say easy.
Oh, okay. I guess what exactly is your thesis before I dive in? Because I don't want to argue a point you didn't make. That would
okay.
be
So I don't say it's easy to optimize. I say that there's more potential for optimization there. The conversation I was having yesterday was at the P99 conference, and Brian Cantrell was there, who was talking about Rust. So it was
Brian and I go way back.
Yeah. So yes, because I worked at Sun the same time as he did on dtrace and stuff. But anyway, so we were talking about this, and it was the whole idea of the optimizations that you can get with a just-in-time compiled versus statically compiled language. So it's the potential is there.
Got it. Okay. I guess I would potentially, I not necessarily argue with that. I think that does make sense. I don't know if we want to talk now about, just in time versus ahead of time compilation, but I did want to.
Bruno shaking his head.
Yeah, that's like a whole other podcast, I suspect. But I really did think that the comment that Bruno made was really apt about the idea that when that compilation happens, does change the dimensions of the question of like support and like moving things. And if you have like a one-to-many relationship of the runtime to the application, that like changing that runtime is potentially more risky, and then you wouldn't want to move as quickly. I did want to share, it is not quite a one-to-one relationship, but because Rust distributes compiled binaries, one of the things that we have that perhaps you all experience less in the Java world is target support conversations. So it has gotten to the point, particularly with Rust being used heavily in the embedded space, in this case, meaning embedded systems. We've recently had to develop a pretty extensive target tier policy because the support for those targets has become a massive part of our release cadence. And so we have 3 tiers of support that kind of indicate the types of guarantees we give for support for that compilation target. So there's questions about like, should Rust like compile for Nintendo Switch versus like, like your general like, Windows machine. And there's really fascinating questions here from like a legal perspective as well as the maintenance perspective, and the cost there alone and often the commercial interest, I think, makes that space very interesting and potentially really similar to like the JDK proliferation situation. So I don't know if folks have thoughts on that, but I kind of was considering that when I heard Bruno speaking.
Oh, yeah, I got a question for you to understand more about Rust, this concept of target support. So you're saying that it's possible that I can compile, let's say, I want to compile this Rust code to Windows. And then can I easily reuse that already compiled Rust code for Windows for my Windows application that I'm developing? Or do I have to recompile something here?
So if that Windows application is written in Rust, you might want to recompile because then you can optimize it. Because if you have something that's already compiled and it's like here, and then another thing that's already compiled here, you could use them side by side, but if you compile them together, there's almost certainly going to be optimizations you're going to be able to make there. That being said, I've written many CLIs that call out to other CLIs. It's a thing that I just constantly do, and yes, that works.
But it's not like a compiled library that becomes part of the whole native program. It's just one application calling another application.
Right, and if you wanted to compile them together, then it would make a single binary.
But then you'd have to need the source code for that to do a single binary. Right.
Yes.
Okay. So that's another significant difference between these ecosystems, right? One of the strengths of the Java ecosystem is the concept of bytecode, and in having that as already shared compiled code binary as part of like a repository of libraries, and then that bytecode can be injected into another application that somebody is writing without necessarily having to recompile that library. But that library becomes part of your application, of your bytecode, as a single thing later. And that goes back to Simon's point on JIT compilation, that optimization will happen later on. So one of the strengths of the Java ecosystem, the bytecode concept and JIT compilation, these combined allowed a Java ecosystem of libraries and tools and frameworks to grow super fast, and not necessarily having to be open source, because you don't need the source code to leverage that code. So you don't have to recompile that. The recompilation will happen on the fly as native, as part of the JIT compilation. So it's interesting to see that these concepts just drive different forces. So for Rust to really grow, it's sort of like everything has to be open source, where in the Java ecosystem, not everything has to be open source. And that also allows companies to innovate and drive a few things that doesn't have to be open source, but can be free, but will still allow that optimization to happen on the fly. One of the greatest examples of something that is largely used but not open source is the Oracle Java driver for the Oracle database. It's something that is freely available, but you don't have the source code. It's freely available in format of bytecode, but that library will be optimized during the runtime, and it's on Maven Central. Anybody can use that library.
Yeah, I mean, coming back to a little bit more to what we're talking about in terms of updates and so on, one of the advantages that we get from using the bytecodes is it does mean that we have less versions, if you like, because we can provide a Windows on, let's say, Intel 64-bit version, and that's all we need. And then what happens at runtime is that depending on which microarchitecture you're using, then you can use whichever relevant instructions are available for that microarchitecture. So we don't have to build specific versions for the specific chip architectures, so that we have a proliferation in the sense of that as well. So that's one advantage of using the bytecodes.
So on a previous Foojay podcast, we had someone who's working on robotic lawnmowers, and one of their early prototypes was actually an embedded system based on Java that literally ran the bytecode. And so they could run things on their desktop for as much as they could simulate the robot and then deploy it to this thing that was out in the yard cutting a lawn.
Yeah, there are several stories about robots and in logistics also implemented in Java. There was a company a few years ago that wrote a paper or press release or something that they were running Java for logistic robot control. But back to like Java ecosystem and proliferation of OpenJDK, when we talk about sustainable open source models, the OpenJDK project, I do believe it's a great example that not many people outside the Java ecosystem can observe. When we see projects from the Apache Foundation that has not the most, but one of the most commercially friendly licenses, there are several projects under the Apache Foundation that allow different vendors to provide binaries of their versions of such project and charge for that commercial support. So the OpenJDK project, even though it's GPL 2, it does also allow such arrangements in commercial agreements, and that allows different companies to provide different values and also different relationships. Sometimes it's not the price, sometimes it's not the features, sometimes it's just like, I like you more than like the other person, so I'll go establish this commercial agreement with you instead. So that's a powerful mechanism that allows the Java ecosystem to grow both in terms of like open source, but also in terms of commercial arrangements. Yeah, so one other thing that I would like to add, kind of connecting back to this Rust discussion, is in recent years now, when Java 9 got released, Oracle changed significantly how the OpenJDK operates. In the past, we used to see the Java runtime environment, and now such concept is not necessarily required anymore for several applications. It's just for, in recent years, companies like Azul and Bellsoft, they do provide a Java runtime environment, which does not have the developer tools as a convenience for developers that were in that model before. But right now, developers can just go with the JDK, and what we see is this trend that applications, Java applications, not libraries, but Java applications should consider embedding a Java runtime with the application itself. So the Java application gets shipped to the customer with the Java runtime already. So if you think about desktop applications, one good concept is Electron to understand this idea. So I go and I create my MSI or my DMG for macOS or my Deb and RPM for Linux. The JVM, the Java runtime goes along with my application. I'm not just shipping a jar file, I'm shipping a whole thing that the end user doesn't even have to know it's Java, in the same way that the users install Slack and Microsoft Teams and Discord, and behind the scenes, it's Electron, but the end user doesn't know. my mom doesn't know she's using Electron when she talks to me over Teams, but she doesn't care, right? So that's the sort of like idea with Java now, where applications, especially end user applications, get shipped with the Java runtime. And for server-side applications, that concept is not necessarily a big thing, but there are ways to optimize the Java runtime for such particular application that will be deployed on the server, so that the Java runtime is not a general purpose runtime. It's a runtime specifically for that application. So it will only contain the APIs required to run that application and some other optimization that can be generated upon creation. So we might see this idea of, I have to have my Java application now with the Java runtime for Windows, for Linux, and for Mac, instead of just having a jar file that is cross-platform. But in the library space, that concept still continues. You just publish your library without the runtime because that library will be reused by different folks.
Okay, so in this case, it's the application owner, the person who's building and packaging it, who's going to make the decision about which JDK their application runs with, whether it's Bellsoft, Azul, Microsoft, or Adopt, or Oracle, rather than in the past, where on a system, somebody would install a system-wide JRE and make that decision.
Yeah, exactly. Like in the past, somebody would have to go install Java across 20,000 desktop computers in the bank, or in the hospital, or in the government office, right? And then somebody would have to manage that and make sure that they don't break things. So basically, that's why some companies stay with Java 6 for that long, because it's a lot safer. But now with this concept being pushed, the application is the developer bundles the runtime. So we might actually see, as I said before, like Java updates, major updates happening much more frequently, because now you can just ship your application with the Java runtime together without the end user having to worry about, or without the IT manager to have to worry about, oh my God, no, don't update Java because that will break other applications. So that's one of the nice things about this concept. And that's why I'm part of the team No More JREs.
All right. So as we have no more JREs, one of the ways that we can consolidate this and make the ecosystem better for everybody is when companies have an opportunity to compete, as a couple of you do, but we also have the opportunity to cooperate in a large scale ecosystem and really make things better for everybody. So Bruno, Dmitry, Simon, Ashley, you're on Rust, so I won't ask you about the JDK. What are some of the ways that each company contributes back to the primary OpenJDK project to build this community ecosystem, as well as differentiating in their own area? So what are some of the contributions that you've made back to the core project?
I would mention the support for Alpine muscle systems that allows to build much more slim containers when we deliver our applications to clouds, for example, like Azure and other clouds.
Yeah, it's all about being part of a community, isn't it? And so what you find is that all the sort of major people who are involved in different JDK distributions will contribute back to the OpenJDK, and that's really the important thing. A lot of that is about the maintenance. One of the ways that OpenJDK maintains updates is through security patches, and those are developed by the vulnerability group in the OpenJDK. It's a closed group, even though it's an open source project, it's a closed group, and there are representatives on that group from pretty much all the main distributions. So Bellsoft's there, Microsoft's there, Azul's there, Red Hat, Oracle. So a lot of the work that goes into creating those security patches isn't like, it's not just Oracle doing that. It's all the engineers who work on that who contribute to that. But then there's a lot of stuff as well. So, Dmitry talks about the Alpine muscle builds that they've been working on. At Azul, we do things like we've been contributing to the Apple M1 architecture, the new ARM processor that they've got. So there's lots of different things going on. There's all sorts of JEPs that are coming from outside of Oracle. So there's lots of things on that. Hang on, Bruno's asking, what is it? Is it muzzle? Muzzle.
I believe it's Musel.
Okay,
I've heard it.
We need another podcast.
So there's lots of contributions coming from outside.
It's been backported to 11 together with Microsoft.
Yeah, that's something interesting. So Microsoft and Bellsoft are in conversations in backporting some of the Alpine, not some, sorry, the Alpine muzzle support to older versions of Java, because Alpine muzzle support only came to OpenJDK after OpenJDK 16. At OpenJDK 16, sorry.
We have it on JDK 8. We've tried to upstream the changes to that. We haven't managed to do it yet.
No. Azul and Bellsoft have done significant work in porting the changes in Project Portola, which is the project that manages the changes in OpenJDK to support muzzle, and that those changes to be upstreamed, they have to be. There's a lot of work. It's not just here's the patch. There's a lot of work that has to go along that. So the upstream update project for the older version of Java, there's a lot of risk in breaking things. So you don't want to break an older version of Java that is maintained long term with an LTS flag. So that's the sort of like conversations that Microsoft and Bellsoft are having now, and Azul is welcome to participate on that as well, because in the cloud space, Alpine has seen significant adoption, especially in containers, simply because of its footprint, of how small it is. I particularly don't see that much of value because it's cloud and storage is not that much of an issue anymore. But customers do want that, and we just have to be customer focused. And if they want, they will get it.
All right, so thanks a lot. What we set out today was to talk about the number of JDKs and explore the concept of why there are so many different JDK distributions. And it seems like the theme of what we talked about is that all the JDKs are compatible with each other because of TCK and the fact that they follow the same bytecode standard, and that each individual JDK gives an opportunity for that vendor or that provider to build new things like support for Alpine muscle or some other aspects, and that the choice of which JDK is used because of JLink and techniques where you ship the runtime is more often made by the application owner rather than the system-wide JRE distribution. So the choice of JDK is not from a compatibility perspective, but from a licensing, usage, and kind of an extra goodie feature.
There's something I would throw here, and maybe we do need a follow-up podcast on this, but one thing that I would like to see in different OpenJDK vendors is more like a use case-focused OpenJDK distributions. That's something that we don't see yet, but I'll give you an example. OpenJDK has too many parameters. The JVM has too many parameters for optimization and tuning. And many of those parameters come with defaults. So when you run the JVM, lots of values have defaults. Why are we still stuck in this concept that the JVM has to have defaults that are general purpose and you don't know the use case, so you just go safe, very conservative with those values? Why don't we have JVM profiles? Why don't we have our OpenJDK distributions for specific use cases? Here's an OpenJDK distribution with the JVM with different defaults for this particular scenario, like a server-side applications or client-side applications or container-based applications, or even better, characterized applications like IO-bound applications or CPU-bound applications or memory-bound applications. Why don't we have that? And that's definitely perhaps another podcast, but I'll just throw it here so everybody has a struggle managing time.
Yeah, we can definitely do another podcast on JDK switches, when to use which one, why there are so many switches, and how to essentially do like a T-Pain style auto tuning of the JDK.
Yeah, because that actually goes back to JDK 5 with ergonomics. So yeah, there's a whole nother podcast. Let's not get into that now. Let's talk about that on another podcast. Because
give me a foo, give me a J, give me the friends of OpenJDK.